Hello everyone, welcome to In 5 Minutes. In this video we are going to see the gamma function. So what is a gamma function? Gamma function, anything which is represented in this form is known as gamma. This is known as gamma of n. So what is the equation of gamma of n? The equation of gamma of n is nothing but integration of 0 to infinity e raised to minus x raised to n minus 1 into dx, where n is greater than 0. So if we have any equation in this where integration is 0 to infinity, we have e raised to minus x term and we have x raised to n minus 1 term into dx, then this equation is nothing but gamma of n. So gamma of n, we can solve this equation, and after solving this equation we can have a gamma of 1. So what is gamma of 1? Gamma of 1 will have equation something like this, that is integration of 0 to infinity e raised to minus x dx. When we solve this, integration of e raised to minus x is e raised to minus x upon minus 1 and the limits of integration. So when we put e raised to infinity, e raised to minus infinity is 0 minus e raised to 0 will be 1 and this minus 1 here. So we get gamma of 1 as 1. Similarly, we can prove that gamma of 2 is nothing but also 1 and gamma of half is root pi. We all can prove this, but now in this we do not need any proof. We just need to remember some basic gamma. Gamma of 1 is 1, gamma of half is root pi. So any equation in the form of this is known as gamma of n. This will be more clear when we see the problem on this. And we have one recurrence property of gamma function. What is that property? We can prove that gamma of n is nothing but n minus 1 into gamma of n minus 1. So this will be our new gamma of n minus 1. So this can be represented as n minus 2 into gamma of n minus 2 and this n minus 1. Similarly, we can represent gamma of n minus 2 as n minus 3. I am subtracting 1 and taking the gamma of that term and so on till we get 1. So if you see, these terms are nothing but, let's say our n is equal to 5. So this will be 5 minus 1, 4, 5 minus 2, 3, 5 minus 3, 2, and 5 minus 3 will be 2, and gamma of 2 we have just calculated as 1. So this will be 4 into 3 into 2 into 1, which is nothing but 4 factorial. So we can say that gamma of n will be equal to n minus 1 factorial. This is very important property, that is gamma of n is equal to n minus 1 factorial provided n is a positive integer. This property is valid only when n is a positive integer. It should not be a fraction. So this is one property. Again we have another. We know that gamma of n is nothing but n minus 1 into gamma of n minus 1. So what will be a gamma of n plus 1? If we apply this property, it will be n into gamma of n. I am subtracting 1 from this. So we can write as gamma of n. From this I am writing gamma of n here and I am taking n in the denominator. It is nothing but gamma of n plus 1 upon n. So this is one of the property.